This video is looking at the water cycle and how the different fluxes and pools and reservoirs connect to cycle water around this planet. So since 1972, Apollo 17, the mission went out into space, and it was the first time the astronauts looked back and took a picture of Earth in its whole entirety from that perspective. And we saw a whole different view on our planet. We saw it basically being blue for the oceans and the vast amount of water on this planet, not only in the oceans but in the atmosphere with the clouds, and the appreciation and understanding of how water is cycled around our planet from different spheres all through the biosphere, and the integral role that water plays in the ability for Earth to not only sustain life but also to recreate rock and other systems. This is the Earth Science Classroom. The water cycle is one of 5 biogeochemical cycles that exist and operate on Earth, with the main purpose of sustaining life on this planet, the biosphere. However, the water cycle goes far beyond just sustaining life. It was the origin of life through the ancient oceans. It is involved in tectonics. It is involved in the atmosphere with the creation of weather and climate and extreme weather. It is related to the wind, which is linked to the temperature differences on the planet and low and high pressure. It is involved with the creation and destruction of landforms and geomorphology. It is involved with the rock cycle. It is involved with volcanic eruptions. So the water cycle is an integral part of the entire planet and how it functions. Water is a chemically beautiful molecule in terms of its presence on Earth, its sheer abundance on Earth, and its existence in all 3 states of matter on our planet at one time, and the changes and phase changes between all 3 constantly throughout the water cycle. So its frozen component is ice, its liquid component is water, and its gas component is vapor, and that is based upon the addition or removal of chemical bonds between the elements based on the amount of thermal energy added to the molecule, which can be linked to the latitude, linked to climate, linked to weather, and also linked to the location of the water. So this is an important part to consider when discussing the water cycle. So in regards to the water cycle, we got to discuss the cycle as a system, and the system has the inputs and outputs. In this case, it has the pool or sink or reservoir being that storage where the water is going to be held for a given time, and that given time is referred to residence time, or RT. So this could be a long period of time in terms of the Earth's history, could be in the hundreds of millions of years or thousands of years, or it could be a very short time in terms of a few days or even minutes. And then we have the flux. We have the connection and the transference of that water in different states of matter, in different amounts, different time periods, between the sinks or between the pools, and we can analyze how this is moved to understand the whole system and how it works and connects. So in terms of the flux or the fluxes, that is the movement and transfer of the water between the storage areas. Firstly, for the water cycle, we're going to consider the main pools or reservoirs or storage areas where water is held for a given time. And this can fluctuate based on the type of sink or pool. But we have 100% of water on this planet, of which 97% is held or stored within our planet's oceans. So the salt water or saline water, and that equates to about 3.5% salt concentration by weight, and this is where the majority of the water is stored between the Atlantic, the Pacific, the Indian, Arctic, and Southern Oceans, and any seas that are also connected and associated with each ocean basin. Then the other 3% of water that exists on Earth is split between various storage or pools with varying residence times. First one is any land or surface-based water being held, or in the ground or crust or soil or sea floor, and this is all termed terrestrial. And this is a small part, so about 0.9% is groundwater, and about 2.1% is held in the ice caps, the glaciers around Antarctica, around Greenland, around the northern hemisphere, in areas like Canada and Russia, Siberia, Alaska, and also the sea ice that forms over the winter in the northern hemisphere over the Arctic Sea. A small amount is held in soil in terms of rivers and stream flow, organisms, and any kind of lakes or ponds. Then the other storage area or pool or sink is the atmosphere in terms of the water vapor and any liquid water held within the clouds through condensation. And this is a very small amount, and it also does not stay in this pool for very long, so you have a very short residence time compared to an extremely long residence time in the oceans, and a varying time within the terrestrial pools and reservoirs. The majority of our water cycle can be summed up with the oceans, and how 97% of the Earth's water is stored or held for a given time in our oceans, and how the oceans then start the large cycle and movement of water between various spheres and across non-ocean surfaces, being the terrestrial component, which includes groundwater, ice caps, rivers and stream flow and soil moisture and permafrost, and also lakes and rivers and organisms, both flora and fauna. So these are included in the fluxes, how water is moved through different states of matter, different amounts, different times between the areas and storage pools and reservoirs, including the oceans across our planet. In this water cycle diagram, we're going to start in the oceans, which is where the majority, or 97% of the Earth's water, is stored in this reservoir or pool as salt or saline water. So we have upwelling, where the water is being moved up towards the surface. Downwelling is from the surface down to the lower or deeper parts of the ocean. And this circulation in the surface, middle, and deeper parts of the ocean, or benthic, is caused by differences in temperature, density, and salinity. So any water that is going to be heated, and it's the first phase change, whereby you have evaporation going from water to water vapor and latent heat, and the energy is stored within the molecules of the water vapor, and as it rises up to a higher altitude within the troposphere, the first layer of the atmosphere, the temperature is going to drop due to adiabatic cooling. Now this will cause another phase change where the water vapor is going to turn back into liquid water and condense, which is condensation, at a LCL or a dew point, and form liquid water and water vapor in the clouds. The clouds will move through wind and changes in pressure and weather systems and climate, and based on latitude, and this is called advection. Then we have precip over any terrestrial land masses, and we have the addition of water on land, different types of precip, and we also have the addition of water vapor going straight back from snow and ice and glaciers, which is called sublimation, which is where you have intense heating and the ice would turn straight into gas and miss out the middle phase change, which is liquid. Then we also have the interception of any precip before it hits the ground by any vegetation, most likely trees or shrubs or bushes, again based on the biome and based on the latitude. You also have the addition of water vapor coming off the land, which is called evaporation, or if there is evaporation of any flora or vegetation, we call this transpiration. So you combine both, you get evapotranspiration. Then we have the addition of fresh water from precip on the land, which is going to shape the land, which is weather and erosion, and transport sediments within the water. You're going to have stream flow and rivers flowing downhill with gravity. You have the accumulation of water on land through any impervious surfaces or bedrock, which is the creation of lakes and ponds, and maybe even small cases in puddles. You have the effect of temperature on the water on land, which is going to be melting or freezing. And then you have the water, which is going to flow over the terrestrial surface, the relief, the terrain, and affect the geomorphology, and also flow into the soil, which is called infiltration, and then percolation through the soil and create soil moisture. Any kind of porosity in the soil and bedrock, you'll have water flowing through with gravity into these spaces and air pockets and voids, and you'll create groundwater and groundwater flow with gravity, which is expressed in the water table being the highest point below the surface, and any large accumulations of water are called aquifers. Any additional water that is from precip that flows over land is called surface runoff or overland flow, which is an addition to stream flow or stream water. So you add in the different fluxes, the movement of water between the three main pools or reservoirs, which are the oceans, the atmosphere, and the terrestrial component of the earth, and how water is moved between all three as a very large cycle, and how this cycle is connected and linked with the other biogeochemical cycles. For example, the leaching and percolation will move both nitrogen, phosphorus, and sulfur through the soil, will aid in assimilation. The water cycle will link up with the rock cycle and create weather and erosion and depositional environments of new sediment in different areas, forming new landscapes. The rise and recession of the tides, erosion of coastlines, the rising of sea levels to submerge or expose more land around the planet, the expansion and retreat of glaciers and ice caps based on the climate and based on any kind of extinction events of any life on Earth. So the water cycle is so influential in everything that the Earth does. Every mechanism, every process, every system is going to include water in some capacity. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.